So till now we have learned what factors are and how to find them. We've also seen what prime numbers and composite numbers are. So today we'll start with factorization. Now factorization means breaking a number into its factors or writing the number in terms of its factors like this. So if you're trying to factorize 36, think of the numbers which when you multiply you get 36. You can write 36 as 9 into 4. Yes, you can write 36 as 12 into 3. Or you can write 36 as 6 into 6. So this we say we are factorizing 36. That is, we are breaking 36 and writing it in terms of its factors. All these are factors of 36. Okay, and when you multiply any of these two numbers, you are getting 36. So this is called factorization. Okay. Now as you can see, the number 9 here can be broken down further into its factors. The 12 can be broken down further into its factors. 6 also can be broken down further into its factors. Okay, so we're not going to do that. We'll just move on to prime factorization. Now what is prime factorization? Prime factorization means you will break the number into its factors, but you will break it in such a way that the numbers that you multiply are only prime numbers. Okay? Prime numbers we learned in the previous video are numbers which have only two factors, 1 and the number itself, like 2, 3, 5, 7, 11, 13, 17, 19 and so on. Okay? So let's see how we can break a number into its prime factors. Now the first method is using factor trees. Now let's see what factor trees are. Okay, let's say the number that we had is 36. So I'm just going to write it in this box here. Okay? Now what two numbers can I multiply to get 36? You know there are several pairs. We had 4 into 9. You had 1 into 36. You had 6 into 6. You had 12 into 3. Okay, so you can use any of these combinations. Okay, any of these pairs. We're not going to use 36 into 1 because it's going to give me the same result here. Okay? It's not going to help us. So we're not going to use this. We will use any of these other three. So let's use 4 into 9. Okay, so I'm just going to make branches. Okay, and I'm just going to write 4 and 9. So this means that 4 into 9 gives 36. Now is this a prime number? No, 4 is not a prime number. So you can further break this number down into its factors. Okay, so I'm going to make two branches again. So which two numbers when multiplied will give you 4? That is 2 and 2. So 2 2s are 4. Okay, so 2 is a prime number? Yes, it is. So you do not have to break this further into factors. What about 9? Is 9 a prime number? No, it's not. So we're just going to break this into its factors. Okay, so again I'll make branches and 3 into 3 is 9. Okay, so is 3 a prime number? Yes, it is. So that means now you've completely prime factorized 36. There are no other numbers besides prime numbers. So this is known as prime factorization, and you're going to write it in this way. You're going to write what is at the end of the branches. So you can write prime factorization of 36 is equal to 2, 2, 3, 3. As a rule, you will write them in ascending order. Alright. So you can do the same thing. Instead of, let's say, using 4 and 9. Okay, suppose I first break the factor into 12 and 3. So I am breaking this into 3 and 12. So is 3 a prime number? Yes, it is. So you do not have to break this further. So now we'll go with 12. So 12 can be written as 2 into 6. Yes, 2 6 are 12. Is 2 a prime number? Yes, so you do not have to break that further. So we have to worry about only 6. So let's make the branches. And now can I write 6 as 2 into 3? Yes. So do you see what is at the end of the branches? Here it's 3, here 2, here 2 and then 3. So again we are getting the prime factorization of 36 as 2, 2, 3 and 3. So no matter how you start, the result is the same. Alright? Let's do another prime factorization using factor trees. Let's take the case of 72. Can I write 72 as 8 multiplied by 9? So 8 9s are 72. Is 8 a prime number? No, it's not. So we'll just break this into 2 into 4. 2 multiplied by 4 gives 8. Is 2 a prime number? Yes, it is. So don't break that further. Break 4. 4 is not a prime number. So we'll break 4 as 2 into 2 is 4. Now 2 prime numbers. So we factorize this part. Okay. Now we come here. 9 can be written as 3 multiplied by 3. Okay. So 3 is a prime number. So we factorize that part also. So what is at the end of the branches? That's 2, 2 and 2. So 2, 2, 2 and then 3 and 3. So this is a prime factorization of 72. So if you multiply all these numbers, you will get 72. 2 2s are 4, 4 2s are 8, 8 3s are 24, 24 into 3 is 72. Okay, so the next method of finding the prime factorization of a number is by using division, where we repeatedly divide the number by a prime number until you have 1 at the end. Okay, so let's say you are finding the prime factorization of 18. Okay, remember we have to use only prime numbers to divide. So these are some of your prime numbers. Okay, so take the smallest prime number, that is 2. Can 2 divide 18? Of course it can. This is an even number, so all even numbers can be divided by 2. So now instead of writing it on top, I am going to write it here. 2 9s are 18. Okay. Now the number is 9. Now you have to divide 9 by a prime number. Can 9 be divided by 2 completely? No. 2 4s are 8 and you will get 1 as the remainder. So move to the next prime number, that is 3. Can 3 divide 9? 3. 3s are 9. Now we have 3. So again 3 1s are 3. So finally you have 1 and your prime factorization is complete. So when you write this, you're going to write prime factorization of 18 is equal to, write all these numbers in ascending order. So you have 2, 2, 3, 3. So 2 into 3 is 6 and 6 into 3 is 18. Okay, so we'll take the example of 56 now. Okay, so 56 is an even number. So think of a prime number which can divide this completely. You can start with 2 or you can use 7 directly. 7 is also a prime number. So we can also use 7 directly. 7 8s are 56. So in order to do this quickly, okay, instead of dividing by 2, I am doing it by 7. So that is why you need to know your tables by heart. Okay, up to 12 you need to know your tables by heart. So now you have 8. This is an even number which can be divided completely by 2. So 2 4s are 8. Again 4 is an even number. So 2 2s are 4. And lastly we have 2. So again 2 1s are 2. So after you get 1, your prime factorization is complete. So the prime factorization of 56 is equal to, write all these numbers in ascending order. So 2, 2, 2 and then 7. So 2 2s are 4, 4 2s are 8, 8 7s are 56. So this is how you can do the prime factorization using long division.